has been going on. I'm pretty close to ending my project now. I only missed a little bit. I have the coding, but it has to work first. So I can show you where I am now. If I can get the screen, just a second. Sorry, share screen, whole screen. Yes. Okay. Can you see a white source file?
Yes.
Okay, good. And just a second, I will show you a little video first. Here we go. That is where we are ending up now. If it works, yes. Okay, what you saw was my emulator running, and the new stuff is that the lamps, all the LEDs are showing what is going on in the machine. And just to show you, I'm inspired by this one. This is the original Motorola 6800 machine, and that is my very first Motorola machine. But coming back to what is going on here, you can see most of you will recognize this line. If you have put it a few times, you'll see something like that. And I had one problem, that was getting enough memory. And Brad made a little miracle, and I got a lot of more memory. But in the end, I needed just a little more. So maybe I have more free bytes here than you have in your system. And that is because I have been into the ENU file and manipulated the size here. Brad has set off 100 kilobytes here on the heap, and I have adjusted it to 110 without problems, I hope. So, but I cannot keep on doing that. So I wonder where is the limit of where I can steal some extra memory. And what you see here is my own development system. And in this window here, I have my source code. In the other window here, the black window, that is simply the terminal. What I found out here in the end, when I had something like 15 files I had to load before the system is running, I had some papers on the disk telling do this and do that and remember that. And I found out that why not putting all those instructions to myself into another source file. So I'm now using the source file to make my own notes. So I've started to call them the manual files, and you can see I have a manual of how to load the program. Of course, in the end, it will be embedded, so it will start automatically. But now, when I do the development, I have to start all over. And you can see here, that's a command line here. I have more than 11 very big opcode implementation files. That is because there is something pretty close to 200 different opcodes in the microprocessor. So I use my own source manual system here to load. You see the first thing I'm doing is including the Altair stuff. That is a software that is controlling the LEDs and the all the switches on the box you saw. The next thing that is doing something, yes, just an important thing. When I have an include here, I will include this software, but that will include this one, emulator also. And this one will include 11 files. So it's a long nested file of loading forth codes into the system. So in order to show you the picture you saw before in the movie, you saw the screen was showing something from the computer, from the emulated computer. That is a complete operating system in the Motorola world. You have 500 bytes here, 512 bytes, and it's loaded into the memory location E000 in the 64 kilobyte RAM. This I do here when I init the Altair. I will get memory and load all the vectors and all the program from the MIGBook. I better tell you that MIGBook is the operating system in the Motorola computer. That was one taking up half a kilobyte. And I have some comments here. And finally, I'm setting the program counter in the virtual machine to the entry point into MIGBook, the operating system. And I show the status of the virtual machine just before it's running. So that loading all that takes something like 1 or 2 minutes because it's thousands of lines I'm loading. And in order to spare you for the time, I've done it already here. And I started by asking here, where are we in memory before loading all the software? And here we start loading the software. And now we saved 1 or 2 minutes here. We're loading all the software and copying the operating system into the RAM area, asking for a status, and we get a status in the emulated machine. And see the program counter is set to EODO. That's the endpoint in the operating system. Okay, now I can say, where are we now? We are here, and I've swapped the two numbers. And so we have the size, and if we ask in decimal, you can see the source has been compiled into memory, and it takes up something like 48 kilobytes. So that was why I had to expand in the INU file. Okay, I've asked here in Forth, still in Forth, but how have we set up the virtual Motorola machine? You see the program counter is set to the entry point, and we have some registers A and B, stack point, and so forth. So if I write one now, that is command that will start the virtual Motorola machine. So this prompt, this asterisk here, is the signal from the MIGBook operating system that I can enter some commands. I only have something like 5 or 6 different commands. One is seeing how are the registers. That has to be in uppercase. So that is the register A and B, and index point and stack point and so forth. You can see I'm working with the system. I can set an address, tell the operating system I want to dump out what do we have in memory. I will just make a short one. You see I enter an address, E002. That's hex address where I can enter a starting point. That is E150, E1BF. So now I have set some pointers. That's an address E150 and ending address E1. And one of the commands I have is punch, and now Motorola operating system will punch out the memory I set starting and ending address from, and that is kind of a memory dump, but it is in a special Motorola format. You can see there's an address here. I hope it stops pretty soon. Yes, it's stopping. You see, I asked to dump address E150. That is the starting address, and here is the content in the memory and a checkpoint, a check checkpoint byte or whatever you call it, some checksum there. That is one of the commands in the processor. And you see it is running pretty slow. But in fact, what you see on the screen was what you got in the late 1970s. The terminal maximum speed for this operating system was 300 bits per second, 300 baud. And the emulator is not running very fast, but what is really taking up time is updating of all the displays. You see here, just reading all the LEDs and not pointing to the LEDs and checking for the switch is happening in a subtask. And when I'm doing the update of the lamps, all the LEDs, it is done in a multitasker and is read in by a 2-port 8-bit E²C extender. So that is working on the 100 kilocycle speed. I hope I can make it to 400 kilobyte speed, but that is the really speed limiting factor in the whole system. Okay, that was what I'm up to now. The only thing I really need is being able to enter programs when the processor has stopped and do that on the switches and make changes in the memory and start it again. But all the lamps and LEDs are working, just missing the very, very last part. Okay, that's about it. I better stop sharing a screen.